Welcome, future inventors. Today, we're exploring injection molding, the process behind countless plastic products. Imagine a superpowered squirt gun shooting hot plastic into a mold to create almost any shape. The secret to a great part? Wall thickness that's not too thick, not too thin, just right. If walls are too thin, parts crack or break. Too thick, and you get slow cooling, wasted material, and ugly defects. Thick walls cause sink marks, craters on the surface, and warpage where parts twist out of shape. Thin walls can lead to incomplete parts called short shots or fragile products. Getting wall thickness right saves time, money, and headaches. Different plastics have ideal thickness ranges. ABS likes 1.2 to 3.5 mm, polypropylene 0.8 to 3.8 mm, nylon 0.75 3.0 mm. Stick to these guidelines for a strong, good-looking, and efficient part. Remember, the Goldilocks principle is your foundation for plastic design. Avoid extremes, find the just right for your material. This balance is the first step to professional results. Master it, and you're already ahead. Let's see why uniformity matters next. The right thickness is only the beginning. Now let's talk about keeping wall thickness uniform throughout your part. Think of pouring pancake batter. If it's even, it cooks perfectly. If not, you get burnt edges and raw centers. Uniform walls mean even cooling, smooth plastic flow, and fewer defects like warpage or sink marks. Parts with consistent thickness are stronger, more accurate, and fit together better, just like Lego bricks. Problems start when thick and thin sections are side by side. The thin cools fast, the thick lags, causing stress and warping. Your top design goal? Maintain constant wall thickness everywhere. Start with a simple, uniform shell before adding features. This one rule solves most injection molding headaches. Uniformity simplifies manufacturing and boosts quality. Make it your design mantra. Sometimes, you can't keep every wall the same thickness. When you must change, do it gradually. Abrupt changes create stress points and flow problems. Think of a highway ramp, not a brick wall. Use a gentle, tapered transition at least 3 times the thickness change. This smooths plastic flow and cooling, reducing defects. Corners are stress magnets. Sharp inside corners can crack. Always round internal corners with a radius at least half the wall thickness. For outside corners, add the wall thickness to the inside radius. Rounded corners distribute stress and make parts stronger. These small tweaks prevent cracks and warping. Smooth transitions and corners are key to robust parts. Need extra strength? Don't just thicken the walls, add ribs. Ribs are thin supports that boost stiffness without adding mass. Keep ribs about 50 to 60% the main wall thickness and no taller than 3 times the wall. Too thick and you'll get sink marks. Too tall and they won't fill properly. Bosses, cylindrical features for screws, should be hollowed out to avoid thick spots. Connect bosses to walls with small ribs, gussets, for extra support. This strategy saves material, speeds up cooling, and reduces defects. Smart use of ribs and bosses means lighter, stronger, and cheaper parts. It's efficient design that pays off in every way. Use these features wisely for top results. Let's wrap up. Uniform wall thickness is your #1 rule. Follow it to avoid most defects. When changes are needed, make them gradual and smooth. Round all internal corners to prevent cracks and stress. Use ribs and chord bosses for strength, not thick walls. These choices save material, cut costs, and speed up production. Thoughtful design means fewer problems and better products. Apply these principles and your parts will be strong, attractive, and efficient to make. You'll avoid costly revisions and delays. Mastering these basics sets you up for success in plastic design. Now, go create something amazing. The world is waiting.